All right, welcome everyone. Thank you so much for joining us today. My name is Kyle Butler. I'll be your trainer and host. I'm really excited to take you through our technical training on smart assembly solutions, where we'll explore the 3 core steps to error-proofing your manufacturing operations. This training is a collaboration with Pico MES and Zmark Fluid Power. Here is what we'll be covering today. So I'll start with an overview on how to conduct your application assessment. We'll discuss the importance of model selection based on your specific application, and then I'll discuss tool integrations and show you live how programming works. Lastly, I'll pass it over to Pico to cover how these tooling systems can integrate with your plant network and how all of this ends up affecting your return on investment and user experience. So just another quick introduction. Again, my name is Kyle Butler. I manage our tooling and assembly product lines here at Zmark. And with me is Brian Bao, the Chief Operations Officer at Pico MES. Before we get fully started, here's a little bit about Zmark. We're your local Ingersoll Rand authorized distributor, and we have 4 locations that provide local support throughout California. We have hydraulic service centers, and our sales and engineering teams are very knowledgeable in a broad range of industries and applications. In addition to Ingersoll Rand, we're also an authorized distributor for a myriad of industrial manufacturing products, including Parker Hannifin, Enerpac, and many, many more. You can easily download our line card here at zmark.com/linecard. And lastly, Zmark is a stocking distributor, and we offer value-added services like testing and repairs. We also do a lot of custom systems work like hydraulic power units, custom actuators, and of course, hydraulic hose assemblies to any spec your application calls for. And on that note, let's get started on the core concepts to error-proofing your manufacturing process with precision fastening and smart assembly solutions. We're going to kick off today by exploring Ingersoll Rand's QX series. These are cordless transducerized tools, which means they contain a strain gauge transducer built into the spindle, which in their simplest form allows you to capture trace data, control torque, speed, and total degrees of rotation. But the best part about a transducer is that it really grants you access to taking on a full plant integration approach, with Pico MES included. Now, before we get into any discussion about model selection, software packages, or accessories, the most important factor we need to assess is your application. Why do you want to upgrade your tools? Are you wanting to improve accuracy, speed, or output? And what is your current method of error proofing? Are you using click wrenches with traveler sheets and bolt markings? Are you dealing with any scrapped material caused by technician errors? And once we've established some goals with your application, we can look at best practices with tool selection. So this includes tool consolidation. How can we cut the number of tools required for a task? For example, with a QX tool, you're essentially eliminating your rundown driver and multiple click wrenches, then eliminating the time between switching hands and several different tools. We have step reduction. How can we reduce the number of steps a technician needs to take for a certain process? And how can we best utilize data capture both internally with things like corrective action and timed operations, or externally? Many of our customers offer detailed assembly reports to their end customers as a selling point. And then lastly, how all of this in conjunction with Pico MES can really just elevate the ease of use factors and provide some major return on investment. So now that we have a solid understanding of what's important with your application and how to integrate some tooling, we'll get into more details on model selection. First thing you'll need to know is your tool body style preference. The QX family has both pistol grip and angle wrench options available. Usually this is just determined by the space requirements or ergonomics of a given application. You'll of course need to know your torque specs. The QX series ranges from 0.8 Newton meters to 80 Newton meters, depending on the model. And then you'll select your connectivity option. Today, we're really focusing on the connected tool systems. This is QXX and above. But keep in mind, all models can function as standalone tools, which is great for field work, or if plant systems go down, you can easily toggle to offline mode and keep production going. Next, you'll need to know your drive head preference. This is available in 1/4" to 1/2" square drive options, along with 1/4" hex and quick disconnect for lower torque models. Overall, your selection should really focus on user experience for your technicians, manufacturing engineers, and QC teams. Unanimous adoption is really what will maximize your ROI. And here's just a quick glance at some of the accompanying accessories for the QX series. Most notably, on the left, you'll see the QCX controller for programming data collection and MES integration. And in the middle, sort of right side, you'll see these are the socket and bit trays. These allow you to select jobs and presets just by picking up a specific bit or socket. And at the bottom, you'll see Ingersoll Rand's torque analyzer. Yes, you can do your own calibration in-house quite easily, actually. And again, all of these integrate very nicely with Pico MES. And then we do also offer custom kitting solutions for any tool in the QSX family. This is really great to bring accuracy and repeatability to remote locations, and it'll certainly help protect your investment too. These are Pelican cases with very high quality jet cut inserts made to your specific model. So feel free to contact us if you do want to see one of these kits in person. I have a couple of demo kits. So we're going to be reviewing everything in a sort of good, better, best approach here. The entry point being a standalone tool with manual programming, possibly with some ergonomic accessories like a reaction arm. This is good. And the better solution involves implementing a controller system for improved data capture and access to additional smart accessories like those socket and bit trays we saw. And then, of course, the best option to eliminate guesswork and manual setup is integrating with Pico MES, which significantly enhances the tool performance. And you'll see those benefits when I pass it over to Brian. All right, let's see these tools in action. So for context, I am showcasing here what it's like to program and run your tool systems without a manufacturing execution like Pico. You'll notice that it's really simple to do and it's easy to use, but like any good technology, there are a few manual steps and there's a little bit of, learning terminology and getting used to the interface. But if you do go with Pico, on the other hand, you won't really need to worry about programming, and you'll see what I mean when I pass it to Brian. First, we'll get started with setting up a PSET. This is your torque, angle, and speed requirements for an individual task within an assembly. In this case, we're assembling a hydraulic gear pump, which requires the following 2 tasks or PSETs. We have one batch of 4 fasteners for the body plate set to 2 Newton meters, and one batch of 4 fasteners for the manifold set to 3 Newton meters, both of which will be monitoring angle, which is just the number of degrees of rotation we expect from a fastener to ensure we have the correct length fastener. So to recap, we have 2 PSETs for this job, and next I'll show you how to create our job. Here is our job. So the job is just essentially the full assembly. So this is, think of a filing system for all of your PSETs. This job, which we'll name hydraulic gear pump, will set up to contain the individual PSETs in a sequence that you want your technicians to follow. So you create the job, and then to that job, we're adding the PSETs we created in the last slide. Since we've also implemented batch counting, 4 cycles of each PSET, the tool will automatically sequence from one PSET to the next once all 4 bolts of each have been completed. But if there's a problem with torque or fastener length or anything outside of the parameters we've set, the technician will not be able to advance without taking predetermined steps to correct the error. So let's get into how this all looks in the actual assembly. Job is the body plate, and it has 4 fasteners.
So you can see on the screen of the tool that we have 1 of 4 complete, as well as the controller. It's 2 of 4, 3 of 4, and 4 of 4.
Cool, so that's the body plate. Next up is the manifold. So we'll switch to our hex bit and run this batch of 4 fasteners. This time it's 3 Newton meters to 2 to 3,000 degrees of expected rotation. And you'll notice something went wrong there on the 4th fastener. So if you look at the controller screen, you can see we met torque, but we had a low angle. So let's inspect what does this mean? So you can now see the 4th fastener looks very similar, but it is a few millimeters short, putting it out of spec. So we'll go ahead and reinstall the correct length, and you can see this now completes the sequence. Now, there are some additional fail rules you can implement, like requiring a manager override or failing the whole sequence. Whatever control you need is likely possible with some additional programming layers. So let's recap here. I want to ensure we all take away some core concepts on how to error-proof your manufacturing process and how the QX tools, along with Pico MES, can make this easy. Brian will highlight Pico's enhancements to the tools, but first and foremost, you need easy-to-use tools. This means easy to program, easy to implement, and minimal bugs or downtime. When tools are too complicated or not flexible enough for your unique application, you definitely will struggle with adoption from your technicians. As you saw earlier, the QX tools are extremely easy to use and are designed with the technician in mind. The next big factor is data capture. Every rundown, timestamp, and product code can be recorded with the QX series alone, and it's stored as a CSV file for easy exporting for your files. And where Pico MES really helps enhance all of this is just the organization of that data into customizable dashboards with filtering options and search features. And overall, your goal is to have smart outcomes. Adopting smart practices will result in smoother assembly process, and you'll find it easier to balance high quality standards and speed with data capture analysis. Zmark and Pico are here to help you include smart technology and work instructions and provide flexible programming. For the grand finale, Brian from Pico, I'm going to pass it over to you, and you can show what I mean by all this.
Thanks, Cal. I appreciate it, and appreciate you taking some time to invite Pico along. So where Pico steps in is the error-proofing layer. So we're a software that error-proofs your shop floor first and foremost, and then builds you out to a full-blown MES. That's where you need to go to with a series of modules that comes along with it. The things Pico does, so where Kyle talked about programming into each controller at each station, we pull that offline so you can set that up as plug and play integrations where you don't need folks to go in and code each of the PSETs. It's a drop down menu within Pico. And then we pair that with visual worker guidance. So work instructions done faster than you can do on PowerPoint, and then give you that trace data and data collection. So each of those cells, so where Kyle talked about having the CSV files at each one of those controllers, we pull that all together and give you effectively a full product summary that comes along with it. And what we've really done is tried to make this all commoditized and democratized, so that it takes less than 3 hours to get everything set up and running on your shop floor. If you want to. So just to break that down a little bit further, one of the things that pairs really well with the IR tools that Kyle was talking about is a set of digital work instructions. So creating a layered content that feels a little bit like PowerPoint, but can set up multiple faster than that, and then giving you a full flow of each of your products through what would be called a digital twin on the shop floor, where you're able to drag around, and if you have to shuffle for each of the different products lines, or if you need to launch a new product line, enabling that whole process so that the workers can focus on what they're good at, which is putting things together, and your engineers can push out the data and push out the updated specs with a controlled fashion. From the digital part of the digital workflow, the next kind of key secret there is the connecting tools. Pico has some 150, almost 200 family of part tools. It's over 3,000 different tools that you can connect to the whole Ingersoll Rand range. We make available through a no-code integration. So all of the programming that you saw Kyle do there onto the controller, like I said, you kind of pull that up back into the software, and you're able to parse the Ingersoll Rand tools with scanners, with printers, with scales, with just about any other connected device that's available, commercially available, so that as your cell comes together, you have all that data coming back in, and then it's all, if you got serialized part numbers, all that trace data from the tools gets instantly parsed to that serial number. And if you don't, you can do it by batches and other things, but it gives you effectively a full history of everything that's come down your line instantly and without driving inefficiency to the operator. That's where these tools are really exceptional, is that instead of the old-fashioned way of the operator going in and keying in each individual activity, I did this to 3 Newton meters, as you saw Kyle do, or if I had this issue, it all instantly gets pulled in, and the operator, like I said, can focus on really adding value to the product. And then the trace data gets provided back to the engineer, so they can go look for where improvements need to be or where things need to be tagged for critical to quality. So once you have the connected tools, like I said, you're really about focusing on the operator experience. Most of our customers see an increased output, 10, 15% in the first 30 days. That's just because they're not doing a lot of those inefficient steps of logging the data or trying to figure out where the paper traveler went with, or trying to understand where the workflow, the paper workflow is, and flipping through the pages back and forth. The whole system integrates back directly to the operator. And we've had a number of customers come through integrating with the digital tools that Kyle talked about in our software, where they were able to get folks that hadn't previously succeeded in manufacturing to succeed in manufacturing, whether that be from retail or whether that be from some fast food chains. So it's really about creating an experience that drives the operator. And then once you have the operator working as effectively as possible, error proofing their stages, it's where do you get all that traceability, both traceability for the product, but also traceability to understand what's critical to quality and what's critical to delivery, and being able to understand any variants that come along. So where you have one person torquing down those 4 bolts and it might take them 50 seconds, you might have a second operator coming through and it might take them 2 minutes. And you'll see that instantly flagged in our software. You have a variation between your operators, and you can go dive in to understand, is one not following the process as succinctly as possible? Is one having a hard time with the bolts? Is one having any number of issues? Is the torque gun they're using having a hard time as opposed to somebody else's torque gun? Giving both, like I said, both the actual operation traceability as long with the part history that comes along with it. And to Kyle's point, you can then provide that back to your customers and point out that you have all this data and this capability to improve their cycle. And then the real secret sauce that comes along with that is we deploy within hours onto your shop floor. So, and we're focused on an on-prem solution first and foremost. So we provide edge devices and provide a server that sits right on the shop floor, connects to all the tools, pulls all that data so you have no latency with your tools communicating back and forth, and then use the cloud as the secondary service for all the analytics and data to be backed up to that effectively, and also provide the remote support that comes with it, so that you get all the benefits of being on-prem, but also all the benefits of having a cloud solution that sits behind it. And then, like I said, all trying to put that at a reasonably democratized price that's accessible to the small and medium enterprises and on up. I'll hand it back over to you, Kyle.
Thank you, Brian. So just to recap here, we've covered the 3 core steps that can help error-proof your manufacturing process. We started with the application assessment. This focuses on improving accurate and speed specific to your application, error-proofing, and addressing scrap and quality issues. We've covered best practices to include consolidating tools, reducing steps, and using data logging for error-proofing and technology-enhanced corrective actions, and integrating smart features with Pico MES, ensuring a plug-and-play and easy programming, offering wireless and portability with flexibility and providing strong ROI. We've also demonstrated how to make precision fastening quicker and easier with proper tool selection and how to program controllers for efficient operator experience. And lastly, we covered how to use collected data and maximize plant productivity with Pico MES.
So this is the Smart Assembly Solutions training. It's a technical training that can help you improve your plant efficiency by error-proofing your assembly production through new technology integration. So if you're interested in an in-person demo, we're happy to come on site to your facility. You're very likely to get Kyle, and he's a friendly guy. So you can see this and test the tools for yourself. And you can reach out to us at sales@zmark.com. Our team is very responsive and knowledgeable about a variety of applications. You mentioned the controller will show the job steps while assembling, but it looks like it's on a PC. Is it available on a computer as well?
So the software itself is not something you would run on a computer, but you can easily mirror the controller screen onto any monitor if you want that on your shop floor. And then obviously, like Brian mentioned, this wouldn't even be necessary to have up if you're running Pico because it's all integrated into the work instructions themselves.
When there is an error with the assembly, how would the operator know what's the issue or how to fix it? How would QC know this was fixed?
So that kind of depends on the level of oversight that you want to implement with fail rules. Different fail rules are available. You can kind of rely on your operators to make corrections, or you can have a whole sequence. You can have the line kind of shut down so that part gets put aside, and then quality control would see how things were fixed based on reviewing the data. So if if there was a failure or error, then they could look at the next following sequences to make sure the proper correction was made. And again, all of that is very well enhanced with Pico. Brian, I don't know if you want to touch on any of that.
Yeah, so similar to the way the controller works for IR, we effectively pull that back for all the connected tools at a station so that you have the 3 layers. If an operator can flag it and it's something easy for them to fix, the software will just say, hey, there's an error that's been caused. We'll note it in the history of the data and they can go fix it. Or you can have the system flag it to a team leader who has to come over and badge in, and then they can fix it online again, still providing recordable what happened and what the flag was. And then the 3rd layer is if it's a major error, you can have that part pushed offline and all the trace data that's come up to that line being put into your quality clinic or whatever, or the like. That whole history gets put with the part, and then they can go in and assess what actually happened and how to resolve that offline if you're moving parts at a faster speed.
ZMark,